So this image dot flip left, image dot flip top bottom, and so on, they are fixed constants that we can use. Right? We can try to see if they are there. Image dot um, flip top. Once you import pillow, you automatically get these constants imported. So instead of typing a 1, which is hardly understandable, no one's going to memorize all these, right? We can always use more meaningful constants that are predefined for by pillow. So just use this. So one, straight off, we understand, once we read this, we understand that, oh, we're trying to flip the image, yeah, and assigning it to a new variable, image for A. And so that's flipping upside down, flipping left to right. Let's run this and see. Okay, that's the original one. Then we save, 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 save. Then this is the resized version, the rotated version, the upside down version, the left flip to right version. Yeah, okay, so depending on the file image and the speed of your computer, it may take a little bit longer or really, really fast because you have a fast computer, but you will get these. All right, so you will get to see these effects that I'm looking at now. So this is exactly what I do. There's nothing that I'm doing that I'm not showing you. So if you feel that this is really cool and powerful, because now the image is our dough that we can, massage it any way we want, flip it, turn it, almost like a burger, right? So yeah, but there's also still a little bit of a sort of a insufficiency because we can only do something to the whole image, right? We would like to like take it apart, that segment of the image, this part of the image, and maybe piece together, enlarge it or whatnot, and give special effects. So that is exactly what we have gone through in the classroom. And now let's try a few more tricks. Now, first we can create a new image over here. Okay, so we're going to create a new image, and that is basically what we can do over here. Let me just try to open up the code. Where's my create new image? Yeah, okay. All right, so we can create a new image, and then we will copy from different segments of the original image, which is image 1. Okay, so we will directly copy these 4 commands from the slides and generate image 2, 3, 4, 5. Let me see if I can, yeah, maybe I don't do this because I'm going to overwrite that. Um, we can save this for later, okay? All right, so we copy these 4 and enlarge and resize and crop and all that. And then we will be able to create a new image. So image.new is going to create a new canvas for us, and it's particularly large, larger than the sizes that we have cropped from. And so we're going to paste them, right? As we calculated earlier on in the classroom discussion, we will paste it as these very, very carefully calculated positions to give this collage effect. All right, so let's see what's going to happen. And this hexadecimal number, we know it's hexadecimal, starting with a hex. It's hexadecimal, that means base 16, all right? FF will be red, 255 red, 128 green, and 16 times 2, so 32 blue. And then we'll get an orangey kind of background. So let's run it. Okay, we get the images saved again, resized again, rotated again, flipped upside down again. And there is our collage, right? So it's a little bit blurred here because I think the image was a little bit shaken when it was snapshot. And we managed to crop out dynamically in real time. So these were generated sort of right now. They weren't pre-stored. They were extracted out, cropped out directly from image 1. So, and then we paste different croppings into different corners of this collage, and this is our new image, right, with these nice borders around. So that's looking good. All right. Okay. Then what's coming up next is we can actually also create a new canvas. All right. So we create a new canvas. Yeah, this is what we wanted just now. Image new RGB of size 300 by 200. Okay, so we can comment out all these for now. Okay, so let's also try to uh, comment out all the resizing and the saving. All right, so let's comment out them. Okay, then at least when we run, it'll be much faster rather than having all the uh, images being shown. So we can comment this out. So not shown. So we have a new image and we can play around with this by showing image 8. Okay, so let's see what that brings us. That's the original one, and this is the new one. So we no longer need the Python Windows Explorer because we have convinced ourselves that we can save them. So this is the new image. Let's just take a look closely at how we generated this. Image.new give us a new image like this, right? So this is a blank canvas. We want it in 3-layer RGB, so no transparency, of size 300 by 200, so that's correct. And the background should be initialized to a color of this nature. What is this nature? 255 red, 255 green, so that gives us yellow. If the blue is also 255, we'll get white. But no, so the blue is 32, so almost closer, almost nearing 0, right? But just a tint of blue that we cannot really visually distinguish, but that's predominantly yellow. Next, we are going to paste, all right? So we are going to paste. Now, earlier on in the collage, we pasted images, but we can paste a color. We paste a color blue at this point that we discussed. So, right, so we can paste the color blue. And if we run it, we'll see this time round, yellow image. Oh, we have to show again. So it is actually pasted, but we are seeing the old image 8, but we need to uh, show it again. So remember, this show is a static copy. It's not linked to dynamic updates. So when we change image 8, we need to run the show again. That means a new window will be created. So we see an initial yellow and then a decorated yellow with a blue box, which is exactly done by the paste command here. Yeah. So we can now delete the show and do all our modifications. We're going to paste another red dot, one dot. We know it's one dot because it's 100 plus 1, 50 plus 1. Right? And then we can paste another green, well, RG, so it's green, RGB, green at the rightmost line from pixel y equals to 10 to y equals to 180. Yeah, or actually 179 inclusive, and then we show it. Okay, and then of course we can also get pixel. We ask image 8, can you go to the location 99, 50? Well, it's a sea of yellow, right? So it's going to print 255, 2550 yellow, or 32 because it's got a tint of blue. And then if we ask image 8 for the pixel tuple at position 100, 50, which is where we painted the red dot, then we should get the red dot. We should get 25500. So that's our red, full red, no green, no blue. Okay, so here, let's see if we can expand. Yes, we can, right? So when we enlarge it, oh, I hope you can see this enlargement. The rectangle is quite clear. Then we see this red dot. I hope you can see this red dot. Yeah, this is the largest I can go. So this red dot here is our fruit, our the fruit of our labor, right? Okay, and that's one dot here, and we can certainly see this green vertical line. It's green color, and it's extending not at position 0 but position 10, and it's stopping way above the bottom at 20 pixels before the end. We know that because that's what we constructed, right? Okay, so this hopefully shows you how you can manipulate the pixels, set them to certain colors. And of course, if you sort of programmatically decorate the pixels, you can actually generate very brilliant and mesmerizing images just from formulas and equations. And also we get to see the pixels as we predicted. We see a yellow at position 99,50, but shift right by 1 pixel, we see a red dot, which is absolutely correctly based on our construction. Okay, so far so good. I hope you're quite convinced that this image library works brilliantly. Okay, next up, I would like, first of all, to maybe let the computation go, but don't show it. Okay, so we can leave the printing. We can print a line separator. Okay, then what we can do is we can try to crop, resize, and do a bit of thumbnailing. Okay, so this is what is shown here. Okay, so we crop out, then we show, and then we resize, and then we uh, compare it with thumbnailing, right? So we show, and let's see what happens. So original picture, this is the cropped version, right? So this is the cropped version. Yep, okay. The cropped version actually will end up being shown here, okay? Then we have the resized version, right? The resized version, which is looking a bit longish on the horizontal side. Yeah, so we can resize the whole image is squeezed into this dimension. And if we resize to a dimension of 400,50, the image will really look compressed, condensed, compressed, whatever, right? So it will be quite distorted. And finally, we see a thumbnail which looks kind of correct in aspect ratio. Yeah, and our thumbnail is stored in